In this question, you are given point A and B and they are on the same root wave. Imagine this is the undisturbed position of the wave, this is the wall, and this is how the root wave will look like when you move your hand vertically up and down perpendicular to the direction of the wave. Root wave is a kind of transverse wave. And because both point A and B are on the same wave, you should also know that regardless whether it's the wavelength, the period, or the frequency, they are the same. Now the next thing is take a look at the graph here. This is a displacement time graph. So there are two information you can get directly from the graph, and they are the amplitude and secondly the period t. So let's start doing the question. Part A, they are looking for the amplitude, and you can either look at graph A or B. They will be the same because the amplitude will be 1.5 cm. Next, frequency is the number of complete waves produced in 1 second. Always with respect to 1 second. And B part 2 here, they're looking for frequency. If you can recall, the formula for frequency is 1 over period. So I need to find my period. So you can either choose A or B to look for the information. If I start from this point until here, that will be 1 period. So it's 0.8 seconds. If you choose to look at graph B, if you start from the lowest point, you will end up to the next lowest point. So you get the same answer. So I sub into the value. So I will get 1.25 Hertz, and if you round off to 2 sig fig, there will be 1.3 Hertz. That's how you solve the first part, rather straightforward. To solve C, now you need to know the exact possible position of point A and point B on the wave. That's why the displacement time graphs here are very important. Another point given to you is point B is 38 cm to the right of point A. Now let's start with point B. At time equals to 0, point B is at its maximum negative displacement. That means it's at its lowest position. So one possibility is here, here, or here. Let's assume point B is over here. Okay, now let's take a look at point A now. Point A at time equals to 0, it has 0 displacement. That means to say it's at its rest position. So it can be here, one possibility, another one can be here. So which one is it exactly? So that's why we need to look at another time of point A. Okay, beside time equals to 0, let's consider here 0.2 seconds, which is a quarter of a period, because one period is 0.8 seconds. So a quarter of a period later, 0.2 seconds, this particle will be at its maximum displacement, the amplitude. And that means to say from 0, time equals to 0 to 0.2 is in the process of going up, not going down. So if you can recall, the next moment, that's how you draw the position of the wave. So this point A, if you assume this is the point, this point A is in the process of going up the wave. And if you consider this point A is in the process of going down. That means to say this point can never be position of point A. So now you have determined one possibility, point A is over here and point B is over here. Of course, point B can be here also. Okay, so let's solve the first part. There are several possible values of the speed, and one possible value, and you're asked to show that is 200 cm per second. So let's assume these two positions first. So from here all the way here, you know is 0.8 seconds. It takes the wave 0.8 seconds to move from here to here, a period. So from here to here, which is a quarter of a period, that's 0.2 seconds, and it's given to you the distance between point A and point B is 38 cm. So using speed is equals to distance over time. The distance between A and B is 38 cm, and the time taken for the wave to move from point A to point B is 0.2, one possibility. So you will end up with 190 cm per second, which is approximately 200 cm per second. So you have solved part 1. In part 2, you are required to explain why there are other possible values of the speed beside 200 cm per second. As if you understand the diagram here, you can actually draw this out if it helps in your explanation. And like we mentioned just now, another possibility of B is here. That means to say, from this point A to point B, the distance will be fixed at 38 cm, but the time now for the wave to move from point A to point B will be 0.2 and another period here. So it's actually 1.25 of a period, which is equivalent to 1.0 seconds. And if you continue with the wave, another possibility of B will be here. And likewise, the distance from here to here will be 38 cm, and the time will be longer, and in fact is 2.25 of a period, which works out to be 1.8 seconds. So as you can see, the distance apart A and B will always be 38 cm, but the time depends on the position of point B. It can be 1/4 of a period or 2.25 of a period, and so on and so forth. That's why you may have different values of the speed of the wave.